Hello everyone, Noel with AWS here. Today I wanted to discuss browser automation leveraging generative AI. I'll show you two different approaches using the Strands Agents SDK and the Amazon Nova Act SDK and demonstrate how I built a working prototype using these tools. Browser tools give us programmatic control over web browsers. Think of them as robots that can interact with websites just like humans do. On the control side, they can navigate to any website, click on buttons and links, and type into forms, scroll through pages, switch between tabs, and execute JavaScript directly in the page. For data extraction, they can take screenshots of what's visible, pull out the HTML or text content, and monitor web pages change or updates. Browser automation isn't just about web scraping, it's about automating any tasks that require a browser. For process automation, teams use browser tools for submitting forms across multiple systems, executing multiple step workflows. For quality assurance, we're talking about automating test scenarios, validating user journeys end to end, and running regression tests after updates. In business operations, this means generating reports from web-based dashboards, monitoring system health through web interfaces, and interacting with vendor portals. Our first approach is utilizing the built-in tools capabilities of the Strands Agents framework. This is a part of the Strands Agents ecosystem. It's built on Playwright, which is a browser automation framework. What makes Strands unique is that it's designed specifically for AI agent integration. You write Python code to control the browser, giving you complete visibility into each action. This transparency makes it an excellent alternative to black box solutions where you can't see what's happening under the hood. The key advantage here is control. You decide exactly what happens at each step, and you can integrate with any large language model you want, Claude, Llama, or even lighter models for cost optimization. Our second approach is Amazon Nova Act, AWS's new production-ready browser automation solution. Nova Act uses a purpose-built model that's been fine-tuned specifically for browser automation using reinforcement learning. Instead of writing detailed code, you can use natural language combined with Python to tell it what you want to accomplish. So, how do you decide to choose between these approaches? Let's discuss some key differences. With control, Strand gives you granular control over every action. Nova Act uses natural language, which is simpler but less precise at times. For LLM flexibility, this is huge. Strands lets you choose any model. You can choose Claude Haiku for simple tasks, and perhaps use Claude Sonnet for complex reasoning. Nova Act uses its own purpose-built model exclusively. Debugging is where you really see the difference. Strands gives you complete visibility where you can see every step, every response. Nova Act is more of a black box. You see the model reasoning and the results, but not the internal processes. Bottom line, it's about having options, and the solutions are very use case dependent. Now, let me show you what we built to demonstrate these capabilities. With the Strands approach, I'll show you the actual code structure, how we execute searches on Amazon.com's site in headless mode, how we capture screenshots, and how we use Claude Sonnet to extract structured data from those screenshots. Then I'll explain how Nova Act would handle a similar task using natural language instructions and letting the model figure out the implementation details. Our example uses Amazon.com to search for products and extract details, but remember, this is the same approach that will work for any browser-based tasks like filling out insurance forms or testing web applications or pulling reports from dashboards. Let's jump into our demo. Okay, I'm in my IDE, and first I'll run through my Strands agent script in headless mode, and then we'll conduct a brief code walkthrough. Okay, so I've ran my script, and let's maximize this. So notice I start with initializing a browser session, and then I navigate to the Amazon.com webpage. The web page takes a few seconds to load. I've added a sleep interval on purpose to make sure the page fully loads prior to searching for a coffee maker. Okay, so we'll wait for that. Now it started the search. So we search for the coffee maker, and then right after the page loads from there, we'll take a screenshot of that page. Okay, and then we're going to send that screenshot over to Claude Haiku to be able to extract the product details based on that image. And we essentially want to extract the first four coffee makers as a JSON representation. Then we'll close the session to the browser. So as you see, the script completed, and it took the screenshot, analyzed with Claude. Here's the JSON representation, and here's the final extracted coffee makers. So let's take a look at our actual screenshot, and it's in the screenshots folder, and this is the screenshot that is established, and it took a picture of these coffee makers, and here is the JSON file that it extracted as a result. Now let's step through our code and see how we actually accomplish this. Okay, I'm in my code, and you see my imports. I'm essentially initializing the Amazon Product Extractor class with our model ID. I'm using Claude Haiku and giving this an Amazon session name. And here you see a function to actually extract the coffee makers. So this is where you see the browser instructions that I'm giving for our browser tool. And I'm telling it to initialize a session, and then this is the following session name and a description of the session. Then I'm navigating to the coffee maker search. I've just hard-coded the URL, but I could have took this dynamically as well. All right. I give that 3-second interval for the page to load. Then I scroll down about 500 pixels. I didn't have to scroll. I just wanted to show you that you are capable of scrolling. And notice the browser script where I define the scroll script here that I'm passing. Then I do another sleep interval, and I take the actual screenshot. So if you recall, the browser tool allows us to take screenshots as well. From there, I am essentially storing the screenshot. And this is just some error handling here. But let's go down a bit further. And if you take a look, I'm reading in our screenshot. I'm base64 encoding it because that's the format most multimodal models require to be able to inference on images. And here's my prompt. I'm saying, take a look at this screenshot from the Amazon search results for coffee maker and extract the following details. Then I'm just making a call to my model here. It's sending it the screenshot, and I am telling it, hey, extract the products and save it to a JSON location as well, and also defining the screenshot path. And again, I close the session once I'm done with all these tasks, and I'm basically just displaying the results in the terminal command line upon completion. And that's the code walkthrough. Now let's take a look at how we did this with Nova Act. Before I start my demonstration, I do want to mention that in order to gain access to Nova Act, you can go to the nova.amazon.com/act website. It shows you how to install the SDK. It shows you how to generate the API key. So that's a requirement of doing this. Then also for the sake of being able to watch our session, what I did is I'm actually in my AWS console, and I went to Bedrock Agent Core, and what I'll do, I'll just maximize it. And from there, if you go into built-in tools and browser use tool, you'll see the Agent Core browser tool. And I'm going to port over my session here. So what's nice about this is you can see the previous session information, and you can actually refer back to these previous session information. So I'm going to go ahead and minimize the screen and go back to my IDE. And from my IDE, I'm going to run my Nova Act script. Now, what it's going to do is it's going to launch a live browser view, but I don't want to watch it in my local browser. I actually want to watch it in my built-in tools session. So from here, I can view the live session from Agent Core. And let's get a better view of it. And so you can see that it's actually going into the web page, And while it's doing it, and it's searching for coffee makers, and it's scrolling down, and I want to mention that while it's doing it, you see the reasoning going on in the logs, right? Where it says, I think I'm on the Amazon homepage. Now I'm searching for the search results of the coffee makers. And then it's going to essentially, from here, I didn't have it taking a screenshot. I actually had it extracting the JSON information and writing it to a file. So, and the extraction is completed successfully. And let's take a look at it. And this is it, coffee maker Nova .json, and this is the extraction that it did. So two different approaches, but let's walk through the code for Nova Act. And let me just minimize this browser. And you see how much different it is. So one, you do need to obtain that API key. And some of this is a lot of extra code just because I wanted to print out the output on that terminal window while it's browsing. But if I was to strip it down bare bones without even writing the file physically, this is the instructions I gave my Nova Act SDK. And let's maximize this a little bit. Is I said search for coffee maker and extract details for the first 4 products on the search results page. For each product, extract the following items and return only a JSON object with products array containing all 4 products. And that's what I did. And it returned the string representation of the JSON. And I just used my code to extract that string and write it to an actual file. But all of the code that you saw for the Strands agents can essentially be replaced with this one snippet of code. And again, everything else was just for me. It's not a requirement. It's just to print the display of the output. Now that concludes my demo. I hope you had a great time watching this. And happy coding. Take care.